Hello my dear students, in this video I am going to teach you how to evaluate the antiderivative of the given function. Here we will take two examples. For the first example, the given function is f of x is equals to x power minus 3. So in order to find the antiderivative of this function, we will integrate this function both sides with respect to x, which is basically the independent variable of this function. So taking the solution of the first question, the given function is f of x is equals to x power minus 3. We will take the integral sign on both sides, f of x, integrate with respect to x. On the other side, we will take the integral sign, right, x power minus 3, integrate with respect to x. Now we will use the formula of the integral of the power function, which is basically x power n integration with respect to dx, and that is evaluated as x power n plus 1 divided by n plus 1 plus c, which is considered as the constant of integration. Now we'll apply this formula. We will see that here n is equals to minus 3. So the antiderivative of this function with respect to x would be x power minus 3 plus 1 divided by minus 3 plus 1 plus c, where c is the constant of integration. So we can mention this c here as c is the constant of integration. Okay, then we can further simplify this function as x power minus 3 plus 1 becomes minus 2 divided by minus 2 plus c, and it can be further simplified as minus 1 upon 2 x power 2 plus c. Now this is the antiderivative of the function x power minus 3 with respect to x. For the second example, the given function is f of x is equals to 3 times cosine of x plus 2 times x power 4 plus square root of x divided by x. And you can note that the independent variable in this function is again x, so we'll integrate this function on both sides with respect to x. So taking the solution of the second example, the given function is f of x is equals to 3 times cos of x plus 2 times x power 4 plus square root of x whole divided by x. Now before taking integral on both sides, we first need to simplify this function. We need to simplify this fraction. So this can be written as 3 times cos of x plus 2 times x power 4 divided by x plus this square root of x can be written as x power 1 upon 2 divided by x. This can be further simplified as 3 times cos of x plus 2 times x power 3, because this is x power 4 divided by x, so that becomes x power 3 plus x power 1 upon 2 divided by x power 1, that becomes x power minus 1 upon 2. Now we shall take the integral on both sides. So this can be written as the integration of function f of x with respect to x, which is equals to the integration of the function 3 times cos of x plus 2 times x power 3 minus x power plus x power minus 1 upon 2 with respect to x. Now we shall apply the algebra of the integration, algebra rules of the integration. We can further simplify this as 3 times integration of cos of x, because 3 is a constant, right? So we'll take it outside with respect to x, plus this 2 will go outside. We'll integrate x power 3 with respect to x, and then the integration of x power minus 1 upon 2 with respect to x. Okay, now the integration of cos of x is sine of x. This should be sine of x, and this should be plus 2 x power 3. So just now I told you this should be the integral of the power function, so that should be x power 3 plus 1 divided by 3 plus 1, plus this should be x power minus 1 upon 2 plus 1 divided by minus 1 upon 2 plus 1 plus c, where c is the constant of integration. Okay, I will further simplify this as 3 times sine of x. This will be written as 2 times x power 4 divided by 4, plus this will become x power minus 1 upon 2 plus 1 becomes plus 1 upon 2 divided by 1 upon 2 plus c, and this can be further simplified as 3 times sine of x plus 2 divided by 4 becomes 1 upon 2 x power 4, and this can be written as plus 2 times square root of x, because x power 1 upon 2 is square root of x, plus c. So this is how we evaluate the antiderivative of the given functions. If you have any questions regarding this tutorial, you can write in the comment section. I'll try my best to resolve your queries. Thank you.